AI's biggest cost, the data processing opportunity. So here's what we all know is that AI is exploding, right? Everybody knows that AI is huge. It's going to be $1 trillion industry. It's blowing up in every way, shape, and form, right? From LLMs, agentic, right? And everything that's going on. Everybody's looking like, how do I integrate AI into my company, right? Because they just want to improve performance, improve speed, and improve the way that they're doing everything. So what people don't talk about is the biggest cost behind it, right? And that cost is data. It's storing data, it's moving it, it's processing it, and it's transferring massive amounts of data between systems. Like when two systems talk, they gotta send the data over, and that's very expensive.
Mhm.
Um, so what we're gonna go into is the AI cost problem, what Raman computing does, your intellectual property, which was cited by IBM, and that's huge, right? I don't think people realize how big that is. That's not a simple feat to achieve, and you did that. Um, how you think about the market and competition, why now, and what does this race unlock? We're gonna do a Q&A, and then go jump into how to invest starting at just $100.
Okay.
So Andrew, before we go deeper, what led you to start Ryman?
So Raymond Computing, I wanted to massively reduce the cost of infrastructure, like processing data and telemetry and things of that nature. One of the biggest things was I was very interested in like grid computing and all this other cool tech in the background. And basically, I noticed that people are spending a lot on wasted computing, especially when you talk about like recursion and processing the same amounts of data over and over and over again to get some end result. And part of the reason I started Raymond Computing is I wanted basically more sustainable computing, more cost effective, more sustainable, more environmentally friendly, and more horizontally scalable computing in general.
Okay. And tell us a little bit more about uh why what how AI goes into it, right? Like,
So a lot of AI companies are focused mainly on LLMs. With LLMs, they're large language models, and a lot of them also do search engine reindexing. So you're trying to reindex billions and billions and billions of search results or data schemas or schemas that end up training an AI on how to respond. And that's sort of a recursive process that ends up becoming more and more and more costly.
okay. And then something we've talked about a couple times. So for a non-technical investor, right? So what is Raman computing in one sense?
So Raymond Computing does data compression. So we build a wide variety of different technologies. The core that we want to focus on right now is data compression. And in one sentence, is basically lower cost of storing and processing data in general. And that's huge because the more data you're able to process and store, the better you can train LLMs, the better you can have a lot of things running. So even your browser, right? Your browser relies a lot on data compression or stuff like MPEG for like videos that you're actually watching right now or webinars being ran on live stream rely a lot on data compression. Another big play is telemetry, right? So if you're talking about like internet service providers and RCA channels, the network packets or the packets that transmit data for different telecommunication protocols, that ends up being very, very extensive, right? So you could end up basically essentially you could end up basically compressing network packets in general. So the actual packet data for information that you transmit could actually be compressed itself. So it affects a wide variety of industries. I know we're talking a lot about AI because AI is like the biggest and hottest industry right now in tech, or one of the biggest, but it affects really everything if you really think about it.
That's amazing. And so you're saying it affects everything. Like what traction do you have? Like how what have you achieved this far?
So we have a wide variety of patents. I have 7 patents encompassing a wide variety of tech that Raymond Computing is doing. Besides even just data compression, we created our own method of computing called signal computing that focuses on real-time computing for signals. In regards to the data compression method that we have, it's been granted in both the US and in China, and it's been cited by IBM and Red Hat And in regards to the computing method, it's been granted and filed just in the US. So
Okay. And how about your team, right? You have a pretty strong team.
yeah, so about 12 people, including myself, across production, advisory, engineering, and marketing. I have an advisor named Charles Oceanramy, who is focused on the African region, mainly East Africa. So one thing that I hope to do, especially in regards to data compression when it comes to telemetry, is to be able to provide ISP services in places like Zambia, in places eventually like Ethiopia, where you could actually have a cost-effective internet. And this doesn't just affect the third world; it affects the first world here as well, because internet services here are becoming extremely costly, less reliable, and you're sort of you don't have actual consumer choice if you really think about it. A lot of these companies, they buy the actual rights to the signal spectrum or to the actual cabling in your neighborhood. So you don't really have a choice on who you get to choose. So this affects a wide variety of industries, and that's a really good thing.
Awesome. And then going from there, right? Like you're affecting multiple industries, right? You have all this technology, you have patents, you're cited by IBM. Like what have investors told you, right?
So I pitched this in Go Fund Yourself, and I got a standing ovation. A lot of people want to see a lot more traction in regards to some pilot case studies, which is part of the reason why we're seeking funding. One of the things that I eventually want to do is build a mini data center for Raymond Computing. So would be able to have a cost per gig approach in regards to actually storing and processing data that we partner with actually other much larger data centers. And then I also want to build my own AI, so my own LLM, which there's already example models out there, and then stuff like the telemetry and all that. So a lot of exciting plans for the future for sure.
Okay, awesome. And one of the things that you went over relatively quickly is that you got a standing ovation on Go Fund Yourself, right? So
Yes.
most people know Shark Tank, but they don't know Go Fund Yourself, and it's similar, right? It's basically the same thing. Speak a little bit about your experience there, how you got there, who the board of investors is there that are willing to invest, right? Tell us how it works.
So they reached out to me via email, and we kind of made a deal for me to be on the show. It had a wide variety of different investors, and basically, if you don't know Go Fund Yourself, Go Fund Yourself is basically like Shark Tank, but for equity crowdfunding and investing and angel investing and things like of that nature. And essentially, Go Fund Yourself is syndicated on Chatter TV, like the Chatter TV network, which plays in hotels, which plays in universities and stuff like that. And I was able to get on the show. I talked a little bit about Raymond Computing. I went too high level and technical, as I'm kind of doing right now, but they ultimately understood the tech, and they ultimately, I think, understood that the goal is to lower costs for a wide variety of industries. And when you're targeting processing and storing data, that could be huge, especially not just for these data centers and what's happening with AI, but for telemetry, for internet service providers, for being able to even have live streams like this. It's definitely going to be a big thing.
That's awesome. And one of the things that is really important when you're talking to investors, right, and what people care about is how defensible is your technology, right? Like, what is your moat? So, can you talk a little bit about that?
Yeah, so outside of the patents that were granted, a lot of what's protected is by via trade secrets. So even if, let's say, the patents were infringed, and some people are infringing it right now, or the patents even go to PTAB or go to zero, the actual the patents just tell you how to do the data compression minus some of the core math. So someone copying like my data compression patent might be able to do 10x data compression compared to a lot of what's out there, but they're not actually probably going to be able to do the full compression ratio that Raymond Computing is going to be able to do. So when you have patents and you have a combination of trade secrets, that is a very good thing, because it's like you're already innovating in terms of like, okay, this is a patent, everyone is able to see that. But at the same time, even if it's infringed or worse comes to worse, the actual math is really what makes this an extremely valuable play.
Nice. And then going from, your patents and how it's defensible to like who are you competing with, right? And why you're set up to win. Um, why is that?
So I've done some of the math and some of the visualizations based off of like what the data compression rates are out there. That's available. Some of the charts are available on my old website, as you already know. But mainly, we have potentially one of the best data compression ratios out there in the market, at least in terms of what's publicly available. And then the other reason that we're able to win is when you're able to have data compression like that, as long as you have the infrastructure to provide services, which is why we're seeking funding. Even with even when we want to provide these services to data centers and AI and all that, the better the compression, the more data you're able to store and the more optimal results. So an example is when you see ChatGPT or Sonnet from Perplexity or all these other AI systems, right? A lot of them, even if you have like the dumbest LLM in the world, right? Which they don't, some of them are very well developed, right? But even a dumb LLM with that's able to process more data can learn much quicker than a smart LLM that's processing data much more slowly or inefficiently. And if you look at the open peer LLM model that we developed, it ran off a single like data set or like few data sets running off my laptop. And the specs are there, and it already has somewhat coherent responses running on Kaggle for people just being able to like send a sentence. So imagine what happens if we actually release an actual like LLM product with the data center with the compression. It's like it could potentially even beat some of these AI companies. Yet alone, that would just be a side thing rather than the actual thing, which is compress and go down.
That's huge. And that's why it's so important. And then going into like why does the timing matter now, right? Like why is now the time for it?
I mean, right now you have all these companies that want to process more and more data with AI. You have stuff like Starlink. So Starlink, it wants to be an ISP service provider, and I'm trying to make my own ISP that utilizes signal telemetry. So there's a lot of new internet service providers also coming into the market. And at the same time, people are trying to make different innovations in computing. I know both inside and outside Raymond Computing, I'm also trying to research a lot into new computing mechanisms and new forms of data compression. So right now the industry is hot and there's a whole lot of people competing. And I think the math that I have and the research that I have out there is much more different. And I have a team, and Raymond Computing sort of wants to be ready to go in this industry.
Right. And how many of them have been cited by IBM?
So far as just the data compression patent, I believe it's been cited twice and then also cited by Red Hat. And
Right. No, so I'm saying like your competitors haven't been cited, right? That's the that's a big
I mean,
big deal.
some might, some might not. One of the things that's very interesting about this form of data compression is the data compression does works on classical computing, but the actual data structure also could work on quantum computing. So this is actually this data compression mechanism that Raymond Computing right now wants to do in classical computing could actually scale to quantum. And that was a big thing. That was one of the things I think also that it excited the investors on Go Fund Yourself for the standing ovation.
That's amazing. That's amazing. Bridget, I see you there. If you have any questions, please write them in the chat and Andrew will answer them at the end. Um, so I mean, we've talked about a lot, right? And that's it's very interesting. There's companies that are investing billions, right? We've chatted a little bit before,
Yeah.
and you said there's companies that are investing billions into data centers, right? Because data centers are going to be so big. So can you speak about how this affects how your technology specifically affects data centers, how it builds on everything that is happening?
So yeah, Kevin O'Leary was one of the people I think we cited that is investing 70 to 80 billion dollars in a data center, and I believe it's in Alberta, Canada, but I'm not sure. And then another thing that was on the news that everyone was talking about was the Stargate data center that's being built in Texas for OpenAI and collaboration with Oracle and SoftBank, I believe, as well as the U.S. government. So 500 billion and 80 billion dollar data center, or right there, or 70 or 80 billion dollar data center right there. Plus, there's a bunch of other people obviously building data centers. One thing that's very important to them, obviously, is going to be the cost of processing data. A lot of these have a lot of ASIC systems, FPGAs, GPUs, all that. So all of them either have a lot of GPUs or they have a lot of different tensor models or neural processing units and all that. And they're basically just you have your GPU or you have your TPU or NPU just plugged in, and it's basically all it's doing is processing data. They don't have any peripherals, and they have like thousands or tens of thousands or hundreds of thousands of boards essentially. And they're trying to process data for training their models or to do recursion and all that. And if you're able to compress the data, both for processing and storing, you could do that much more effectively and waste a lot less computing power to get the same end result.
So they're building, you know, $500 billion data center, one example. Another
Yes,
example, $80 billion data center. Is a bunch of independent providers building data centers, and
yes,
all of them need to expand their margins, right? Because everybody cares about their margins.
yes, yes. So basically, one, it's not even this margins where you're able to process the data in less costs or store data in less costs, but also it's horizontal. It's the horizontal scaling of what they're trying to do. So if you could process more data, you could learn faster. Your models could become much more advanced. They could become much more complex, and you could outbeat the competition. And that's a really big thing for a lot of those players.
Nice. So they have cost savings and faster learning times for their platforms.
Yep.
So it's a win on both sides. I mean, that's insane. Awesome. Okay, tell us about how you're looking into, being acquired, an IPO, potential exit path, and as obvious, before we discuss before we discuss exit, I have to say there's a quick compliance note. This is forward looking and nothing is guaranteed, and outcomes depend on execution and market conditions. Okay, so now tell us a little bit about the exit plans.
So the main goal is not to get acquired. It's to IPO. It's to go public on the stock market and for this company to become a name brand that people invest in, hopefully on the NASDAQ or a similar exchange. So the main goal is to go public. And part of the reason equity crowdfunding is enticing as well is it allows you to meet shareholder cap requirements for number of shareholders for a lot of those exchanges, and it might be able to, depending on how things go, it could help validate that some people are investing for some of those bigger scale VCs.
Okay, awesome. Now, can you give a quick recap for everybody here?
Yeah, so Raymond Computing builds a wide variety of different technologies across different industries, and the core idea is wanting to disrupt infrastructure and telecom. The core technology that we're focused on at the moment is data compression. We believe our data compression could process data and store data more cost effectively. And we're even going as far to build our own LLM model that we hope also could one day compete in the market. We have some data, we have patents that have been both publicized, and some of them have had significant citations. And we have a good advisory panel and team. The goal is to get some initial market validation, get some funding, and eventually, hopefully, build our own mini data center and go from there with hopes to horizontally scale Raymond Computing so that it may potentially IPO or go public on the stock exchange.
That's amazing. For everybody here, I'm gonna drop the link to invest in the chat. We're also gonna email it to you afterwards. There it is. And let's go into Q&A. So Bridget, and anybody else with your questions, please ask. Um, let's see. We have, why is moving data often more expensive than storing it?
So moving data or the processing of data in general is more related to recursive computing, right? So you're recursively going over the same data sets, and then you have different weights or different indicators that you're looking for depending on your algorithm. And the faster you're able to go through the data set and have lossless compression, the more the less the cost. Because if you go much slower, you're using computing power over and over and over again. And then the other thing is the more computing power you have, besides processing, the more GPUs that you have. So the more infrastructure that you'll have to build, the more GPUs that you'll have to you'll have to support that. The more costs in construction, essentially. So faster data processing, lowering costs of construction, lowering costs of the moving of all that infrastructure is going to be a huge play on all that.
Got it. And where does most of the AI infrastructure spending actually go today?
A lot of it goes to the CPUs, and then a lot of it actually goes to those massive data center build outs. And then after they do that, you have essentially wasted computing, because a lot of the methods in order to re-index search engines and all that, in my opinion, is not designed as well as it should be. Like the math ends up having you look at values that are just essentially corrupted, or essentially you're going over the same variable multiple times over and over again. And the simple way of explaining that without going into so much technical details and lecture is just dummy logic. There's better logic out there, and there's better math out there, and there's better structures out there in terms of actual data structure to process that data much more effectively.
Got it. Perfect. And if large tech companies continue investing billions into data centers, how does Raymond Computing benefit?
Well, if more people know about us, for sure. The goal is, again, eventually have our own mini data center, and then have endpoints connecting to that data center where we're actually helping provide compression for the processing and storing of that data. So obviously, you're talking about contracts that could be potentially worth billions, depending on if we have the infrastructure to support that, and people just know more and more about Raymond Computing, which would be a big thing.
Awesome. One thing that we didn't touch over, which I thought was very interesting, is that you're looking to close a potential deal with a government agency, right?
Yeah.
Can you go over that a bit?
Yeah, so we're trying to target a deal with a government agency. One of them is SBR, and then one of them is a different agency where we're trying to target potentially $1 to $1.5 million deal for a pilot. And if we're able to have the infrastructure, it would obviously the deal would probably be closed much faster. And then if we're also able to get funding, we might be able to just fund the pilot ourselves. So it could be potentially a win-win on both avenues. And the goal with that pilot would be to test Raymond Computing's compression on top of its ISP model in a third world country like Zambia, and then use that as a reason to expand potential trade or exports for Raymond Computing throughout the world, and hopefully be able to provide similar services in the US.
Amazing. Awesome. So the link is in the chat. Do you have any final statements for anybody, for everybody else that's here?
Yeah, I mean, I think it's a very exciting industry. Anyone could go and look at the patents that are out there. They can go look at some of the charts and datas. They could go look at the WeFunder page, and there's also the YouTube channel. It's YouTube/at RyComp or /Stark Drones, because before we renamed to Raymond Computing, we were called Stark Drones because we were doing drone batteries and a whole bunch of other cool tech. But there's hundreds of videos out there. There's a lot of cool tests and demos that we've done. We even tried using a weather balloon to send a CubeSat up, which is why you have in one side a signal compute module, and then another side you have a CubeSat in my background photo. So a lot of cool tech. And if you're not going to invest, I at least hope you read about some of those research and you could always feel free to send me an email or send me a connection request on LinkedIn, and I'm happy to talk.
That's amazing. Thank you so much, Andrew. Thanks, everybody. Bye.